Very good morning, students. So, welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8. Our ongoing chapter number 6, sound. Today we are entering to the session number 3. Session number 3. So far we completed 2 classes in understanding the basic concept of sound, like what is sound, how sound is produced, why sound is produced, how sound travels in different mediums, what way sound travels, and what are the different types of waves where you can produce a sound, and some terminology related to sound. These are all the topics what we already learned in last 2 sessions. Okay. In 2 sessions, we learned these things. Today, we'll continue where we left in the last class. But before that, let us see once our material, what we learned and where we stopped in the last class. Okay. So these are last part what we learned yesterday. That is types of waves. First, we learn about the transverse waves and longitudinal waves, which are classified based on the way of propagation, in which direction they are traveling. Based on the way of propagation, they are classified into transverse waves and longitudinal waves. I told you, exchange the heading. So this is longitudinal wave, this is transverse waves. Exchange them. So based on the classification is based on the direction of vibration of particles. If all the particles of wave travels in a direction perpendicular to the wave direction, perpendicular to the wave motion, are called transverse waves. We have seen so many examples also in a video. Second type of waves are where in all particles of medium vibrates parallel to the wave direction. We have seen in the slinky how the waves are formed in slinky. In transverse waves, crust and troughs are formed. In longitudinal waves, compressions and rarefactions are formed. Now, based on the wave motion, what way wave is moving, same waves are classified into progressive waves, stationary waves. Progressive, name indicates, they propagate in a medium without coming back. They never come back to their original position. They are called progressive waves. That may be either transverse or longitudinal, no matter. The second one is stationary wave, which is formed between the 2 fixed points. I told the rope, waves formed in a rope. When you are disturb the rope, the wave forms, they strikes the wall, again they come back. Means progressive, degressive. They overlap to give the stationary waves, where you can find node and antinodes. The highest point is called antinode. The lowest point is called node. Very important. In this, nodes and antinodes are formed. CF. You can check in the diagram. See, one side they are going progressive. After striking here, again they are coming back. Generally happens. So here node, here antinode. At node, particle are zero displacement. At antinode, particle is maximum displacement. Maximum displacement is called antinode. Minimum displacement is called node. Right? So these are the 4 types of waves which are classified based on direction of propagation and the based on the wave motion. Clear? So after sound, as you all know, sound travels in the form of wave. So to understand that only, we discussed about all these types of waves, which we generally come across in our day life. Now, the next part, sound waves produced in a medium. You know, medium is nothing but either it may be solid, liquid, or gas, no matter. Sound produces. But sound cannot travel in vacuum because in vacuum there is no medium. Correct? So, we'll see how sound is produced in medium, how sound travels in a medium, what are the factors influencing the sound to travel. Suppose here I am talking with you in air. Air is a medium. Sound travels at some speed. Same, suppose I am in water. I am in water, and if I speak, sound may travel with the lesser speed. So depends on the medium, sound propagation changes. So we'll see what is the sound, speed of sound. Sound waves produced in medium. Sound waves produced by vibrating objects, right? Already I told. Every vibrating body produces sound. Sound waves are mechanical waves. Mechanical means you have to apply some force. If you apply force only, sound will produce. And they require medium to travel. When an object vibrates, it vibrates the medium of the particles. So why sound is coming? When you are vibrating any particle by applying force, the particles start moving. A particle of medium in contact with the vibrating object will first displace. Then this particle displaces the adjacent particle. Just like in a classroom. Suppose 3 students are sitting in one bench. One is started talking. If teacher don't say anything, the second one also start talking. If teacher is not caring, so total class will be disturbed. Means disturbance will start at one place. It is spread throughout the class. That is called as a same like sound also. Okay. So thus the particles do not move forward, but vibrations are carried out. That person who started talking, he will sit here only. He is sitting in place, but he will tell secrets to other fellows. He will tell some story, something, what happened at home yesterday. That fellow, what will do? He pass to others. Like that, the total classroom will be disturbed. Similar way, the sound also travels. From where a disturbance is created, from the point of disturbance, it passes energy to next particle, next particle, next particle, and it reaches the last point. Right? So some properties of sound waves. Sound waves are mechanical waves which require medium to travel. Very important. Sound waves require medium. Medium is which carries energy. Here I am speaking. How you are getting the sound? Because this is traveling through various means and reaching you. There is some technology is there. Suppose imagine I am in vacuum. You cannot hear me. Because in vacuum, sound does not travel. Because there is no medium in vacuum. Absence of medium you only call vacuum or space. Right? The second point. The sound wave is produced by vibrating object. Right? Every vibrating object produces sound. Third one. Sound waves are longitudinal waves. What waves? Longitudinal means they produce compressions and rarefactions. All the particles of medium travels parallel to the direction of motion. Parallel. Sound waves can, fourth one, sound wave can travel through liquid, solid, or gases. So, sound can travel in all the three states of matter. All the three states of matter. And last property. Speed of sound depends upon the nature of medium. Its speed is maximum in solids. Maximum in solids. Solids roughly around 5,400 meter per second. The speed of sound approximately. So if you see in liquids, after solids in liquids around 400, 1420. Whereas in gases around 360 or 340. Speed means in solids, sound will travel 5,400 meters per second. That much speed will travel. Whereas in liquids, approximately 1420 meter per second. That is second. And whereas in gas, it travels only the speed of 340 to 350 meter per second. Means sound travels greater speed in solids than in liquids and finally in gases. Clear? These are the 5 important properties of sound waves. What they are? They are the properties. So when you move forward again, some more information. The characteristics of sound waves and the factors on which they depend. Why sound is traveling more in solids? Why less in gases? Because some factors are there. There are some factors influence that. That we'll see. So what are the characteristics you see? Characteristics of sound waves. Loudness. Loudness. See, I'm shouting now. I can shout. Suppose side of me there is a lion is there. Lion or tiger. They shout. Whose loudness is more? Lion. That is, loudness is nothing but intensity. How far it is traveling. If I am teaching, even lion lowering, lion sound travels more distance than my voice. Correct or not? That is called loudness. So what is loudness? It depends on the human experience. It is not a scientific unit. Loudness depends on amplitude. Means how much distance sound will travel. Greater the distance travel, greater the. In your classroom, there are so many teachers will come. All teachers will not have same loudness. Some may be very low or low loudness. Some may be high loudness. Even classroom also, when you are talking to your friends or playing games, some fellows maybe shout very loudly. Their voice can reach to the outside the school also. Correct? That is called loudness. Strengthen the sound. How much distance sound traveled. That is called amplitude. Right? The second one, intensity. It is a scientific unit. It is measured in decibel. Or intensity is directly proportional to amplitude. The sound travels more amplitude, more intensity, more decibel. Suppose in a stadium, if you see, public is shouting, they will show the decibels. Whenever a favorite player is entering to the stadium, for example, when Kohli is coming for batting, or Dhoni is coming for batting in IPLs, or any other fellows are coming here, what they'll do? They'll shout. Entire stadium will produce a sound. That is called intensity of sound. That is measured in decibel. I already told. The unit of sound is decibel, which is directly proportional to amplitude. How much distance it travels sound, that many decibels. Our ears also can able to hear only up to some decibels. Right? That is called intensity. So amplitude, that is loudness and intensity. Third one is pitch. Pitch means sharpness. Sharpness in voice. So for example, compared to ladies or girls, boys and gents are having loudness more. But whereas for women or girls, sharpness is more. Sharpness means frequency. How this vocal cord is vibrating. How many vibrations making per second. Based on the pitch. Pitch is the measurement of the sharpness or stillness of the sound. Pitch is directly proportional to frequency. So greater the frequency, greater the pitch, greater the sharpness. right? Sharp voice. It's very beautiful to listen also. That is called pitch. Intensity, loudness, pitch. These three are the characteristics of sound. One more is there. Quality, or it is also called timbre. Quality of sound. So if two sounds have same amplitude and frequency, but their effects in different, then they have different quality. Suppose a tabla is there, piano is there, flute is there, guitar is there. You are playing all four at same time. We can identify what is the quality of tabla, what is the quality of flute, quality of the guitar. Everything we identify. That is identification. Distinguish between various sounds is called quality or timbre. So loudness, which depends on amplitude, intensity is directly proportional to amplitude, pitch depends on sharpness, depends on frequency, and quality. These four are the very important characteristics of sound waves, right? So properties we have seen the characteristics. Now the next one is the factors. The factors on which speed of sound depends. Number one, the speed of sound depends on the nature of the medium. Sound travels slowly in gases and fast in solids. Whether sound is producing in the, for example, you have steel railing at home, steps with an steps made up of steel. You go to the top and hit with some solid. The sound produces there and passed up to the down end within fraction of seconds. High sound. Solids. Say you can drop water in stone, become little less. In air, sound will be little slow. Right? Then the speed of sound increases with increasing temperature. So sound travels faster in summer when compared to winter. In winter, there is so much fog will be there, na? It will restrict the sound. So greater the temperature, greater the sound. Sound is directly proportional to temperature. Next, speed of sound increases with increase in humidity. Humidity is more means density is more. Humidity is nothing but water molecules. For example, in rainy season. So these are the three important factors. One is temperature, one is humidity or density, or even pressure, you can call it as pressure. And most important one is nature of medium, whether it is a solid, liquid, or gas. If it is a solid, what kind of solid it is? Changes from solid also. Iron can travel faster than gold, or wood may be less speed than the iron. So many cases are there, right? These are the three important factors influencing the sound. So properties of sound, characteristics of sound, and factors on which sound depends. Right? Now we'll see one video on same about the factors, then we'll move to the next continuation. Right? Just observe the one video explaining about the factors influencing the sound.
Now we will see the factors affecting the velocity of sound. So the first one, we will just study the effect of temperature. So we have just seen that velocity is nothing but gamma p upon rho. Then rho, what we know that rho is nothing but mass upon volume. So
just
this
proof for the how it affects the temperature.
Mass upon volume. So this one definitely, again I can write it down. So gamma PV upon m. So definitely what will happen if the temperature is going to change? Yeah, so this PV is equal to RT. So this velocity is equals to gamma RT upon m. Yeah, so definitely you can say that. So V is equals to, or V is proportional to the square root of T. So if the temperature is going to be changed, which will affect your velocity of sound, so it is proportional to the square root of t. So it is proportional to the square root of t in case of, that is the effect of your temperature on velocity of sound. Yeah, so velocity is going to increase over there. So similarly, what is the effect
Next,
of
pressure or density.
So we have to see now what is the effect of pressure. So again, V is equals to, you can write it down, that is a gamma P upon rho. Again, rho is equals to mass upon volume. So velocity is equals to, again, gamma P, which is mass upon volume. So velocity is equals to gamma PV upon m. Yeah, so now effect of pressure. So even if the pressure is get changed, so you can say that still, yeah, so definitely according to which the volume is going to change. Yeah, so if pressure get increased, volume is going to decrease. So the PV is always remain constant. So it doesn't change the velocity of sound. In short, it doesn't change the velocity of sound. Yeah, so you can say that it
Pressure
doesn't
does not
change
affect
the velocity of sound. So we can write it down,
This
the
is
velocity of sound, which is your gamma P upon rho. Again, that rho is equal
density
to
and humidity.
density.
How affect the
Then velocity, let's say for a particular medium, that is a gamma P upon rho 1. Then V2 is equals to gamma P upon rho 2. So if you just take the ratio of V1 upon V2 is equals to rho 2 upon rho 1. So simple, you can say that it is inversely proportional to the square root of rho. So that is the effect of velocity on the density. So if obviously density is more, so the velocity is less. Then if you talk about the humidity, so if you just talk about the humidity of your atmosphere, yeah, so for humidity, again, you can say that, so we can say that the air is moist. Yeah, so for moist air and for dry air, so let's say for your moist air, yeah, and then for your
moisture is
dry
it
air,
contains the
so
water
dry air
molecule,
generally
humidity.
the density is greater, and for your moist air it is generally, again, it is a 0.8 or around 0.9. Yeah, so you can say that obviously based on this, so the density of your dry air is greater. So the density for the dry air is greater, so V is inversely proportional to the square root of rho. So this density is greater, so the velocity of sound through the dry air
So this is a mathematical explanation.
greater through
We'll
the
come across in higher classes. It's a totally mathematical explanation. But what clearly says that velocity will be affected by temperature, density, humidity, and nature of the medium. It is not affected by the pressure. Increase the pressure also, there won't be any change in the velocity. That's all, right? Then, after knowing about the factors, properties, characteristics, and factors we have seen. Next comes the frequency of sound. You know, frequency is nothing but I already told, we discussed already. How many vibrations per second? The number of vibrations per second is called frequency. What you can call? Number of vibrations made by a particle in 1 second is called frequency. As I told, the human being cannot hear all the sounds. The audibility depends only on the frequency. So, human can hear the frequency of 20 hertz to 20,000 hertz. This range is called audible range or human range. 20 hertz, that is 20 vibrations per second to 20,000 vibrations per second is called audible range. The frequency greater than 20,000 is called ultrasonic range. Frequency less than 20 hertz is called infrasonic range. In between infrasonic and ultrasonic, there is a human range or audible range. Based on that, we can able to hear the sound. Less than 20 we cannot hear. More than 20,000 we cannot hear. But some animals can be able to hear the infrasonics as well as ultrasonics also. Right? Now we'll see what is ultrasonic sounds. Ultra means whose frequency is greater than 20,000 hertz. We generally will use in the washing powders and all ultrasonic sounds to remove the stains. dry cleaning. They use the ultrasonics only. Ultrasonic waves are the frequency more than 29 kilohertz. They cannot heard by the human beings. Their applications are where they are useful. They are used in detect the cracks in metal. Just like how you do X-ray to know the bone cracks, these ultrasonics are used to do the cracks in metals. They'll pass through the metal and they'll see any cracks or holes are there or not. You get the scanning. They are used to industry to clean the hard to reach parts. The parts which we cannot reach. By passing ultrasonic, they'll clean. So they are using for cleaning also. Third one, they are used to examine the internal organs of human. Just like X-rays, some cases, ultrasonic tests will be done for human body also. They are soft ultrasonics. They are used to monitor the development of the fetus, growth of the plants and all you can see. Ultrasounds are used in sonar to detect the underwater objects. Sonar is their own method. Sound navigation and ranging. So suppose if you see in the ships which are going, by sending this, they can come to know what is there in the water, under the water. You can detect. The rays will pass inside. After cycling, it returns back. Method is there. One method called sonar method. Bats uses ultrasonic to fly in night. Actually, bats does not have eyes. They won't have eyes. But still, how they fly night time? By using the ultrasonics. They can detect the ultrasonics. They can hear the ultrasonics. Ultrasonic waves are used in the homogeneous of milk, homogeneous milk. To kill the bacteria in milk, they'll send the ultrasonic sounds, waves. These waves are used to dishwashers in the process of cleaning the vessels, to remove the hard stains of lemon or some other non-veg and all. They'll use even there are dishwashers are available in the market. No need personally you can clean. They themselves will clean by using the ultrasonics. Dolphins communicate with each other by ultrasonic sound only. Dolphins which are in water, they'll produce ultrasonics and communicate with their family. Easily that I am here, you come, I am there, or somebody is coming to us. Everything is communicated by the dolphins. These all are the applications of ultrasonics in our day-to-day life. Right? It's very nice, huh? See how sound is useful for us in the form of various forms. Some explanation is given for few. How bats uses ultrasonic to catch the prey. Bats search our prey at night by emitting the ultrasonic waves. The high frequency ultrasonic waves are reflected from the obstacle. When it's flying, suppose there is one tree is there, obstruction, or one hill is there. So before that, the rays will go and strikes that will come back and indicates that for the bat there is a stone is there or hill is there. Immediately will take diversion or go and stick to that one, some cases. Right? By detecting these reflected ultrasonic waves, they know the location of the prey, wherever they want. Ultrasounds used in cleaning. Ultrasound is used for clean the parts located in hard to reach places in machine. When ultrasound waves are sent into the machine, due to its high frequency, the particles of dust starts vibrating and get detached from the surface of the objects, get cleaned. Just by sending them, we can get the clean surface where we cannot reach by our hands. Okay, so still many more are there. We'll see in next class what are the more and more applications of the ultrasonics, that is sound waves. So many are there. The sonar method is there, and some more applications, formulas are there with which you can complete the chapter in the next class. Next class maximum we try to close the chapter up to here. Right? Then we can start the new chapter in the again class. Maybe still 2 or 3 are there. How many possible we can complete. Right? So that's all for today. So we learned so many things about the sound today. Properties of sound, characteristics of sound. So audibility of sound, ultrasonics, infrasonics, use of ultrasonics, and further remaining part we'll discuss in the next class. Right? So thank you all the students. Have a wonderful day. Thank you.